John von Neumann, a name whispered with reverence in the annals of science, was a mind of unparalleled brilliance. His intellect and contributions have left an indelible mark on the world, influencing countless fields and inspiring generations of scientists and thinkers. Born in the heart of intellectual ferment in Budapest, Hungary, von Neumann's genius touched upon nearly every field of human endeavour. From a young age, his prodigious talents were evident, and he quickly became a towering figure in the academic world. Mathematician, physicist, computer scientist, and polymath extraordinaire, his contributions reverberate through time, shaping the world we know today. His work laid the foundations for modern computing, and his theories in mathematics and physics continue to influence contemporary research. This essay delves into the life and work of this extraordinary individual, exploring the key milestones and anecdotes that illuminate the depth and breadth of his genius. From his early days in Budapest to his groundbreaking work in the United States, von Neumann's journey is a testament to the power of human intellect and curiosity. Von Neumann's mind was a crucible of innovation, forging groundbreaking concepts in mathematics, physics, economics, and computer science. His ability to see connections between seemingly disparate fields allowed him to pioneer new areas of study and solve problems that had stumped others for years. He possessed an uncanny ability to dissect complex problems, reducing them to their essential elements with laser-like precision. This skill made him an invaluable collaborator and a sought-after consultant on some of the most challenging scientific and technical projects of his time. His work on the Manhattan Project, where he played a pivotal role in the development of the atomic bomb, underscored the real-world implications of his theoretical prowess. Von Neumann's contributions to this monumental project not only demonstrated his technical expertise, but also highlighted the ethical and moral complexities faced by scientists working on such transformative technologies. John von Neumann's journey began in the bustling city of Budapest, Hungary, in 1903. The city, known for its rich cultural heritage and vibrant intellectual scene, was the perfect backdrop for the birth of a genius. Born into a wealthy Jewish family, young János, as he was then known, displayed exceptional intellectual abilities from a tender age. His family, well-educated and affluent, provided an environment that fostered his early development. His prodigious memory and lightning-fast calculations astounded all who knew him. Even as a child, he could perform complex mathematical operations in his head, leaving adults in awe of his capabilities. Recognizing his son's extraordinary gifts, von Neumann's father, Max, nurtured his intellectual curiosity. Max, a banker by profession, understood the importance of a strong educational foundation and took an active role in his son's learning. Tutors were hired to provide him with advanced instruction in mathematics, history, and languages. These private lessons were tailored to challenge János and keep him engaged, ensuring that his talents were continuously honed. By the age of 6, János was fluent in ancient Greek and could converse with his father in the dead language. His ability to grasp complex languages at such a young age was a testament to his extraordinary intellect. His teachers, struggling to keep pace with his voracious appetite for knowledge, marveled at his ability to absorb information like a sponge. They often found themselves learning from him, as his insights and understanding surpassed their own expectations. Mathematics, the language of the cosmos, held a particular allure for von Neumann. He saw the world through a mathematical lens, perceiving patterns and symmetries where others saw only chaos. His contributions to the field were profound and far-reaching, laying the groundwork for future advancements in areas such as quantum mechanics and game theory. One of von Neumann's most significant contributions was his work on the theory of operators, a branch of mathematics that deals with linear transformations in infinite dimensional spaces. His groundbreaking work in this area, particularly his development of the spectral theorem, revolutionized the field of functional analysis and had profound implications for quantum mechanics. As the world stood on the precipice of the digital age, John von Neumann emerged as one of the key architects of this technological revolution. His deep understanding of mathematics and logic, coupled with his visionary foresight, led him to play a pivotal role in the development of the first electronic computers. Von Neumann's most significant contribution to computer science was his articulation of the von Neumann architecture, a conceptual model that laid the foundation for the design of most modern computers. This architecture, which separates the processing unit from the memory unit, enabled the development of more flexible and powerful computing machines. Section 5, Playing the Game of Life, von Neumann's foray into game theory. Beyond the realm of pure mathematics and computer science, von Neumann's intellect extended to the strategic complexities of games. He recognized the potential of game theory, a mathematical framework for analyzing strategic interactions, to shed light on a wide range of social, economic and political phenomena. Von Neumann's seminal work, Theory of Games and Economic Behavior, co-authored with economist Oscar Morgenstern, laid the foundations for modern game theory. This groundbreaking work introduced key concepts such as the minimax theorem and the concept of a Nash equilibrium, which have since become indispensable tools for analyzing strategic decision-making in various fields. Section 6. The Atomic Mind, von Neumann's Role in the Manhattan Project. The spectre of World War II cast a long shadow over the 20th century, drawing John von Neumann into the heart of a project that would forever alter the course of human history. The Manhattan Project was not just a scientific endeavor, it was a race against time, driven by the fear that Nazi Germany might develop nuclear weapons first. His expertise in mathematics and physics made him an invaluable asset to the Manhattan Project, the top-secret American effort to develop the atomic bomb. Von Neumann's unique ability to apply theoretical concepts to practical problems allowed him to bridge the gap between abstract science and real-world applications. Von Neumann's contributions to the Manhattan Project were multifaceted. He was involved in various aspects, from theoretical calculations to practical implementations. His work on shockwave compression was particularly crucial, as it helped in understanding how to achieve the necessary conditions for a nuclear explosion. His mathematical modeling and calculations proved essential in designing the implosion device used in the Trinity test and the Fat Man bomb dropped on Nagasaki. The precision and accuracy of his calculations ensured the success of these critical components, making him a key figure in the project's success. His work on the project highlighted the complex ethical dilemmas faced by scientists in times of war, a topic that would continue to occupy his thoughts in the post-war years. Von Neumann often pondered the moral responsibilities of scientists, especially when their work had such profound and potentially devastating consequences. His reflections on these issues influenced his later contributions to fields like game theory and computer science, where he continued to explore the intersection of human decision-making, ethics, and technology. Section 7, Glimpses of Genius, Anecdotes and Eccentricities. Beyond his towering intellect, John von Neumann was a man of intriguing contradictions and endearing eccentricities. He possessed a razor-sharp wit and a mischievous sense of humor, often diffusing tense situations with a well-timed joke. One oft-repeated anecdote recounts von Neumann's encounter with a classic mathematical puzzle. When presented with the problem, he is said to have paused for a moment, mentally calculated the solution, and then immediately provided the correct answer, much to the astonishment of those present. This anecdote, whether apocryphal or not, encapsulates the lightning-fast processing power and extraordinary memory that characterized von Neumann's mind. Section 8, A Legacy Forged in Thought, von Neumann's Enduring Impact. John von Neumann's life was tragically cut short by cancer in 1957, at the age of 53. Despite his untimely demise, his legacy continues to inspire and influence generations of scientists, mathematicians, and thinkers across various disciplines. His contributions to mathematics, computer science, physics, and economics are immeasurable. The von Neumann architecture, a testament to his visionary thinking, remains the cornerstone of modern computing. His work on game theory continues to shape our understanding of strategic decision-making in fields as diverse as economics, politics, and evolutionary biology.